Okay, so where we left off was I was just about to write the time down here. YouTube only lets me do 10-minute videos, in case you're wondering why that cut off. So this time is going to be negative, and it's 0.8958 seconds. So obviously, it's this one. And so now that we have this one, we can go back over here. We can find our delta dx. Delta dx is equal to Vix delta t 1/2 ax delta t squared. This goes to 0. So delta dx is equal to 80 meters per second cos of 40. And then you're going to multiply that by your 11 point, what was it, 11.37958 seconds that you just found. Of course, you have all the digits in your calculator. And so you end up getting, I think it's 697.38 or something like that meters. Okay, and then the next part asks for VF. So to get VF, you need VFX and you need VFY. VFX should just be equal to VIX. And so that's going to be 80 meters per second cos of 40. VFY, you can do VFY squared is equal to VIY squared plus 2AY delta dy. So VFY squared is equal to, this is 11 meters, not 11, excuse me. This is 80 meters per second cos of 40 squared plus 2 times negative 9.81 meters per second squared times negative 50 meters squared. So this first term should be 2,644.33 meters squared per second squared. And you're going to end up plussing because the negative and negative will give you a plus. And this is 981 meters squared per second squared. So when you add them together, you should get 3,625.3258 meters squared per second squared. And when you take the square root, you should get plus or minus, because that's what you get when you take a square root, of 60.2107. And this should sound, all of these numbers should sound awfully familiar, because look, here they are right here. It's exactly the same numbers. What you get under the square root, the discriminant, is actually your VF. And so if you've already done the quadratic over here, I am okay when you get to this spot and you go to find your VFY if you just say to me that it's 60.2107 because it's what's under the discriminant or what's under the square root. You get two possible values. In this case, of course, you want the negative. It's going down. Okay? And so really, in a way, you could avoid the quadratic. You could find the VFY using this, and then you could go and do AY is equal to VFY minus VIY over delta t to get the time. But really, you're not avoiding the quadratic. What you're really doing when you do that is you're just doing it in two pieces. Because here is your VIY. Here's the plus and minus that you get for your VF. And so there's the A on the bottom when you rearrange your A equals VF minus VI. So really you're not avoiding the quadratic by doing it this way, you're really just doing it in two steps. So do the quadratic to get the time, and then if it asks you for the VF, you don't have to go through it again. You can just say, oh, it's the value under the square root, the discriminant. Okay? So that's number 7. Number 8. Number 8 is kind of tricky, but it really isn't if you understand. So it says this projectile is being shot in such a way that it just clears the edge of the building when it comes down. And it tells you that the edge of the building is 100 meters away. So really, they're giving, I've put 2 for 1. I've given you a ground-to-ground and then a non-ground-to-ground. Okay, so in the first one, when it says it's 100 meters, now it also tells us this is, oops, sorry, this is 150 meters. And it says at this point, this is the 4-second point. And so in the first set of your givens, you have 100 meters and you have 4 seconds. And you have 4 seconds. So from this, you can find your VIX and your VIY, right? So you can do delta dx is equal to VIX delta t, 1/2 AX delta t squared. This goes to 0. So VIX will just be delta dx over delta t. So 100 meters over 4 seconds. So your VIX is just be good if I could divide, 25 meters per second. And then you can get your VIY in the same way as we've been doing, VFY minus VIY over delta t. And if we look at time up, this goes to 0. And so VIY is equal to negative AY delta TU. And so VIY is equal to negative 9.81 meters per second squared. And t was 4 seconds, so this is 2 seconds. So VIY is equal to 19.62 meters per second. And once you have that, then you just go back again and you can square them, add them together, take the square root, and get your VI and your theta. And you should get, what is it, 31 point, I'm trusting the sheet here, 78 meters per second. And the angle should be something like 38.12 degrees, okay? So that's for the first part. Maximum height reached, yeah, we can do that from the first part then as well, because it's just going to be delta dy max is equal to VIY delta TU plus 1/2 AY delta TU squared. And so delta dy max is equal to, is it really 19.62? We've done this problem already. This part of the problem, because remember it's 2 seconds plus 1/2 negative 9.81 meters per second squared, 2 seconds squared, and of course you're going to get 19.62 meters. All right, now it wants the other part. Now it wants you to do the whole piece. And so now you're going to have to use the quadratic to get your full time. Okay, so not bad practice for you to get used to your quadratic. So negative 1/2 AY delta t squared minus VIY delta t plus delta dy equals 0. So again, this will be 4.905 meters per second squared, delta t squared. This will be minus 19.62 meters per second, delta t, and it tells us the height of the cliff is 150 meters this time, equals 0. So fill it in, delta t is equal to negative 19.62 meters per second, plus or minus square root negative 19.62 meters per second squared, minus 4 times 4.905 meters per second squared times 150 meters, all under the square root. And again on the bottom, 2 times 4.905 meters per second squared. How much time do I have left? Okay, we're running out of time here. So when you do all that, then you should get a time of something like 7.88 seconds. Okay? And then once you do that, it wants to know what's delta dx. So VIX delta t plus the stuff that goes to 0. And so delta dx is equal to our VIX that we found earlier was 25 meters per second. And your delta t is 7.88 seconds. Now when you do this, you do not get the answer on the sheet. You get something significantly bigger than the answer, because times 7.88, you get 197 meters. But the answer on the sheet says 97 meters because the answer on the sheet wants to know how far from the base of the building. just this piece, you have to take off this 100 meters. Obviously my diagram is not to scale. So therefore